Hey everyone, I am Miss Hu, your physics teacher. In this video, I will be discussing the answers to a past year question and then we will compare the answers to the mark scheme. For some questions, the answers will be covered first so that I can explain the thought process of getting to the answers, as you will need to know how to get the answers and not just what the answers are. Then, based on the mark scheme, I'll explain why the marks are awarded as such. Question 4. Figure 4.1 shows a heater used to warm the air in a room. A1. State the main method of thermal energy transfer throughout the air in the room. As you should know by now, there are three methods of thermal energy transfer that you have learnt in your syllabus. There's conduction, convection, and radiation. So what this question wants you to identify is which of these three methods is the main method of energy transfer in this picture. So the hint here is that the question has told you that a heater is used to warm the air in a room. So in this case, the answer is very obviously convection, because convection is the main method in which fluids use to transfer heat energy. So remember that fluids include both liquids and gases. Conduction is not the answer because although fluids can conduct heat, air doesn't conduct heat very well. And obviously, it's not radiation because radiation does not involve any air at all. And the question has already told you that a heater is used to warm the air. So when we look at the answer, you can see that yes, the answer is convection. And this would give us 1 mark. A2. Explain how the heater warms all the air in the room. So now that we know that convection is taking place in this picture, we just need to use the process of convection to explain how this works. So where do we start? So remember that convection is about the process of warm fluids rising and cooler fluids sinking. Now, when we want to describe the convection process, you either start with the warm fluid rising or the cooler fluid sinking. In this case, the question has already told you that the heater warms all the air. So that means that there is heat transfer from the heater to the air. So you have to begin with the warm air rising, not with the cool air sinking. Because if you say cool air sinking, that doesn't answer the question. So you have to start off first with the warm air. So what happens is when the heater warms the air, the warm air that is heated by the heater rises. And the reason why the warm air rises is because it is less dense than cool air. So the warm air now has risen. What happens to the cool air? So the cool air is going to sink and takes the place of the warm air, because when the warm air has risen, it leaves kind of a partial vacuum or an empty space. So the cool air needs to sink and take that empty space. So that's what we're going to write. Cool air sinks and replaces the warm air. So the process here then will repeat to produce a convection current. This process repeats and produces a convection current. So this is how we can explain that the heater warms all the air in the room. Let's check the mark scheme. We can see here first mark is given for mentioning that the warm air rises. Now if you had mentioned less dense air rises, they will also accept. So yes, warm air that is heated by the heater rises. And the reason for this is because warm air is less dense than cool air. Now, if you had mentioned that less dense air rises, you will still get the mark. But you also mentioned that the warm air is less dense than cool air because we are comparing the difference between the different temperatures of air. Warm air that is heated by the heater and the cool air that is not heated yet. The next mark comes from any one of the following. Mentioning that the cold air replaces warm air, the cold air falls and the process repeats, or words to that effect, or mentioning that there is a convection current. So any one of these would give you the third mark because this third point is about explaining that there is a process of convection current. In our case, we did mention the process of convection current. So either one of these sentences would give us the third mark. So that's how we score the 3 marks for this question. B. The power of the heater is 2.0 kilowatts when it is connected to the mains supply with an EMF of 230 volts. 1. Show that the current in a heater is approximately 8.7 ampere. So this question is an electrical power question because it gave us the electrical power, the electromotive force, and the current. So we need to use what I call the Poisson-Ivy formula, which is P equals IV. Because this is a show question, I consider this a free mark because I've already told you what is the answer you should expect to get. So we do not start with the current value. We are looking for the current value. So treat this question as if you are looking for the current. So we'll put the equation of P equals IV, where I is unknown. So P is 2.0 kilowatts. We need to convert that to watts. So I'm going to put here 2000 because 2 kilowatts is 2000 watts. I is unknown and V is 230. So if you calculate this, you would get a value of 8.695665 ampere. You don't have to write all those digits out. You just round it to two significant figures, which is 8.7 ampere. And you can add here shown just to say, hey, yes, I got it. So when we check the mark scheme, 1 mark is given for the formula of P equals IV, or if you had written it as I equals P over V. As long as you use the equation correctly, you will still get 1 mark. And of course, you'll get 1 mark for the correct substitution, or just identifying that 2 kilowatts is 2000 watts. Yes, this mark scheme is pretty lenient in this case. So obviously, you're not going to get the third mark for 8.7 ampere because the question already told you that you should expect to get 8.7 ampere. So you only get marks for the equation and the substitution. B2. The plug connecting the heater to the main supply is fitted with a fuse. Fuse ratings of 3 ampere, 5 ampere, 10 ampere, and 13 ampere are available. State which fuse is used. Explain your answer. So the answer to this question is related to B1. The good thing about this question is that they already told you that the current in the heater is approximately 8.7 ampere. So this question, again, I consider another free mark because they've told you that this is the current value and you use this current value to determine the fuse. So you have no excuse to identify the wrong fuse because you already have a reference here. Now let's recall how to identify the correct fuse. Remember that a fuse is a safety component which melts when excess current flows through it. So the value of the fuse rating is the maximum current that can flow through that particular fuse. So for a 3 ampere fuse, when the current reaches 3 ampere, the fuse wire will melt and will cut off the current from entering the device. Because the heater needs 8.7 ampere, obviously, you cannot select a fuse that is lower than 8.7 ampere because the fuse wire will melt. So if you use 3 or 5 ampere, the fuse will melt before the current can even be supplied to the heater. So that means available options are 10 ampere or 13 ampere. However, you must remember that fuse is a safety device. The purpose of this is to prevent overcurrent, that means too much current, from flowing into the device. So if the current is too high, it can spoil the device. So between 10 ampere and 13 ampere, we want to select a fuse that is slightly higher than the current needed. So the best answer in this case is 10 ampere. The explanation for this is exactly like what I've explained just now. We can't pick a fuse that is too low, and we don't want to pick a fuse that is too high. So don't just write that, you also have to explain a bit more detail. The fuse cannot be less than 8.7 ampere because the fuse wire will melt and will prevent the heater from working normally. To be on the safe side, let's also mention that we don't want to select a fuse that's too high. We're going to mention the 13 ampere fuse is not suitable because the current will be too high and might spoil the heater. So I know I've written a lot of things here, but this is the complete explanation as to why we selected 10 ampere and not any of the other fuses. So now let's check the mark scheme. So you can see in the mark scheme, the correct answer is the 10 ampere fuse. So yes, we scored that. When you look at the mark scheme though, it says 10 ampere and, which means that in order to score the 2 marks, you must have not only the correct fuse, but the correct reason as well. So the correct reason is from any of the following. The smaller fuse melts in normal use of the heater. Smaller fuse stops the heater from working. Larger fuse allows too much current. Larger fuse may not melt before the circuit is damaged. The fuse must be higher than the normal current, or that the fuse will melt if the current goes too high, or words to that effect. So you can see in my answer, I've written a lot more than what is needed. They only need you to write one reason. Whichever the case, my answer would definitely get us the other mark. I know I've written too many things. It's just that for me, I like to make my answer as complete as possible, which is why I've written a little bit extra over here. So this would give us 2 marks. So what could cause you to not get full marks? For one, if you selected the correct fuse, which is 10 ampere, but you didn't give the correct explanation. Now, what if you selected 13 ampere instead? If you selected 13 ampere, you can still get 1 mark if you could give a valid reason. In this case, for example, that you mentioned the fuse must be higher than the current needed, or you mentioned that a fuse with a lower value would melt. And that's how you answer question 4. If you found this video to be helpful, click like and subscribe. And do let me know how you have found this video to have helped you. To watch videos on other questions, check out the playlist on my YouTube channel or on my website, physicsrocks.com, to find the question that you are looking for. If you have any requests for a particular question, drop your request in the comments below, stating the year, month, variant, and question number. And if I haven't covered that question yet, I will do my best to come up with the explanation video as soon as possible. All the best for your examinations!